last resort. Because everything on the outside would kill us. We're like crabs in a barrel, fighting to get to the top. Pulled down by everyone else. By justice. That only knows how to place its boot on your neck. By outlaws that couldn't care less if you lived or died. You want to know the way to survive? You fight. Fight like a starving dog, eyeing meal.
So my name is Gary Young. Thank you for coming to this pipeline talk. And I know it's the afternoon, so I hope some of you got some coffee. I'm the general manager of a new studio called Empty Vessel. We have 14 people on our team, 3 of them in the back, near the back of the rows there. That contributed a crap ton towards driving that trailer that we that you guys just watched. We announced our studio earlier this year and announced our game, Defect, just a few weeks ago. I'm actually here doing this talk for our tech director, our CTO, Wei. He's based in Australia, and he had one of his close family members had surgery last week, so he didn't feel comfortable leaving the country. So I said, I will represent for you, Wei. Before I turn to the next slide and talk about table of contents and what we're going to talk about today, tell me how many people are working in startups right now, game development startups. Anybody? Got a couple people? Nice. You 3 back there I know are. You, nice. How big are the teams? Like 50 people, under 50, under 10, small teams, big teams? 18. 18 people, okay, similar size to us. What's that? 3, okay, very nice. Welcome. How do you have time to be here? Just kidding. So part of why we're giving this talk is because we are only 14 people, and we did want to set up all of our pipelines for our builds and development workflows and also for our dedicated servers during our playtest. Part of the reason we did this, we were so aggressive about it and pushing it to AWS, and of course we're in Unreal, as you can imagine with us being here, was to free up time for our engineers, right? We have 4 engineers, we really want them, including Wei, and we want them focused on gameplay, on animation, on rendering issues, et cetera, as opposed to spending a bunch of time on DevOps, keeping our team productive. Do I have any more questions for the crowd before I start? I don't think I do, but great to see you guys. And this will probably not take too long, give time for Q&A at the end. We will get a chance to hear from Wei in a second. He's got a 9-minute video I'll play in a little bit. Okay, this is what we're going to talk about today. First, I'm going to tell you a little bit about what our game is, and then who we are, and then how we work. The whole goal here is that, we're not saying that we're better than every single startup in the world. That's not what we're saying at all, but we have done some things that have led to some pretty good success over the 12 plus months that we've been around. We're taking I will call it a AAA approach to doing things the right way instead of, you got a really small team. Sometimes you tend to run really fast and tend to break a lot of stuff. We don't want to do that. We want to set up our team for success. We don't want people spending 2 hours waiting to sync the latest build, as an example. And we want to keep the build stable for our team, the build stable for our stakeholders, like our contractors and vendors, the build stable for our current investors. We raised seed last year, covering us through early next year. So we want to show them they spent their money well. And also, we're doing a lot of play testing with potential future investors and publishers. I'll cover some of that stuff in a little bit. Process build pipeline in the AWS cloud, and then, of course, our server architecture is also up in the AWS cloud. And I know we talk about the chip Graviton3 in the title of the talk. We're not going to spend a lot of time talking about that. If you have questions afterwards, I can tell you a little bit about the results we found. The long and short of it is, it's a great chip. We're using it for our dedicated servers for gameplay. It is, I think the marketing that AWS put it's out there is something like 30% faster and 50% less power consumption, something like that. Don't quote me on the exact numbers. But we have seen great results. We actually even use the Graviton4 chip, some servers with that chip for our dedicated servers that we set up for the playtest we did in Germany last month. And that went pretty well too. It's a little bit more expensive, and they're not everywhere yet. They're not in, like, for instance, in Australia or Tokyo yet. Okay, what is our game? We are doing this AAA, you guys have all read this while I've been talking, AAA first-person PvP and PvE shooter. It is a 4 teams of 4 game. We kind of call it an objective shooter. We kind of call it a co-op competitive shooter. We got a lot of phrases for it. They're all just generic terms, but it is a very fun game. It is set in a dystopian sci-fi futuristic world. We sometimes joke that our art director is Judge Dredd, certainly inspired by Judge Dredd. It's not a Judge Dredd game, but we're very inspired by that architecture and that world. Run at 60 hertz, of course, built in Unreal 5. 5.5 is coming out very soon, so we'll need to move to that very soon. And we just did a talk. Emmanuel and Jake just did a great talk next door. So if you saw that talk, you're going to see some of the assets that I'm showing up here. Who we are, yeah, a lot of logos. Like I said, 14 people. These are all AAA developers that have a ton of experience. We have multiple people from id Software on the team. From Crystal Dynamics, worked on Tomb Raider, Jake, kudos, and other places that Jake has worked. We have people from Naughty Dog. So it's a collection of people that know how to build games, have been in a part of some of the biggest games in our industry, and we come together because we want to do something new, right? We want to do a new IP where we get to make the creative calls and creative direction. It is scary, it is risky. But it is something that excites us at this point in our careers and everything that we've learned from a creative standpoint, from a process standpoint, from a tool standpoint, and we're excited about the challenge. We are also not doing this alone. I mentioned 14 people I've mentioned a couple of times, but we have a hell of a lot of partners that are helping us on this journey. Epic has already been super helpful, not just with Unreal 5, but even other tips and tricks. And we have an open channel to multiple people at Epic, which is exciting, and they've been super helpful. Running id Software, as I did a few years ago, as we rebooted Doom 2016, and Doom Eternal. If you guys played that, we had our own engine, and there was many times people on the team would come, like when you're late at night, you're having a beer, you're working late hours, and people saying, "Damn, this would be so much easier in Unreal." And so we get to work on Unreal now, all of us do. Amazon is a great partner. I think they're I don't know if Diane's in here, but they actually sponsored this talk. They've been great. We lean on them a lot for our pipeline and our dev infrastructure. I say Steam, even though it may be a bad word in this conference that we're at right now, but we do right now for all the playtests. We actually host our client up there and download it there for our internal team, and of course for all the partners that I talked about earlier. When I say internal, I should also, well, I'll say this in a second. And these are a bunch of other partners and friends that are even all the way down to advisors who are helping us as we look for a publisher or look for the next investor down the road. This is the theme for the conference that we're all at right now. This is Epic's theme. Point here, the reason I include this here is that we are very focused on doing this together, doing this with a large group. You saw, even though our team is about 14 full-timers right now with other contractors, we won't grow up to much more than about 50 full-timers is our current plan, and then there'll be contractors and vendors and other partners that help us. But it's a very, we're very collegial, for lack of a better word. We do believe that great ideas can come from anywhere. We want everybody on the team to feel valued. Even if you're on the extended team, you may not be a full-time employee of Empty Vessel, but you're still a part of our ecosystem. You're still one of the stakeholders in our success. And so we're a firm believer of that last word. And what's the old saying? If you want to go fast, go alone. And if you want to go far, go together. We are a fully remote team. And this is just the full-timers up here. Taylor back there is in the upper left. He's in Seattle, so he came down to visit with us. I'm also in one of those in the upper left. Jake is in one of the 4 that are in Texas, 3 in Austin, 1 in Dallas. We have 2 artists in Europe. 3 of our engineers, including Wei, are in Australia. And most of the time, Emmanuel, our game director, is in Tokyo, but you never can tell. The sun never sets. He's at a different place all the time. Digital nomad. And the AWS, I'll just quickly, I think I'll mention that later. So I'll skip it. But anyway, we've set up game servers in all those different locations. Okay, starting our studio. What were some of the big problems we need to solve from an operations standpoint and a productivity standpoint? So we have a worldwide team. You guys saw that in the last slide. We didn't, I don't know if I was joking here or joking with somebody else earlier, but we want to keep people productive. Anytime you have a startup, some of you guys do have a startup, you understand there's no money tree out back, right? We want to keep costs manageable. And our biggest cost, as you can imagine, as it is in our industry, is people, right? Is salaries, is benefits. And so if someone's taking 2 hours to sync the latest build, you're wasting a lot of money, all right? So we want fast access to Source Depot, people to be able to work and be productive, want to unblock them. Game development is hard, and we're always blocked by lots of different things, and we didn't want our build pipeline and access to Source Depot to be a blocker. Worldwide playtest, yes, I mentioned that already. We playtest at least twice a week right now. Sometimes it extends up as we're coming in on a major milestone. That is really critical for us because, yes, we're making a shooter, and probably most of the room has played shooters, get it, but every shooter is subtly different, and we are doing some brand new innovative things here. I like to refer to as 4 games in one. It's a PvP game, right? Right now, we're going to do PvE later, but rounds are about 15 to 20 minutes, and it's almost, I was kind of joked that it's almost like 4 games in one because each of the 4 teams have different objectives. Sometimes those objectives cause you to clash with other enemy teams, right? And they certainly do at the very end of the round. So, but we needed to set up our architecture and our pipelines to make sure that we could support those global playtests internally, but also when we wanted to set up, say, really great ping when we were at Gamescom in Germany a couple weeks ago, right? So we set up a server just outside Cologne. And AWS was key to helping us and supporting that with the scalability we got with their global footprint. AAA approach to security and reliability, yeah, we didn't want to be losing the build or losing our source assets, right? That's a no-brainer. But if we just had it running on Way's laptop and our Source Depot running out of Way's laptop, that would not be the smartest approach, right? So we took a more mature kind of approach to that. We wanted to take a more mature approach. I mentioned earlier, we wanted to minimize engineering support needs, so you heard that earlier. So those are problems we wanted to solve. And this is a quote from Way. Yes, cloud native is kind of a key word there. We are remote right now, and we plan to always be remote. I guess one thing I didn't mention on the map slide is, you guys probably all understand in this room, game development, whether it's engineers or artists or animators, wherever it is, we have a global talent pool now. We have access to a global talent pool. And so we didn't want to say, hey, everybody, move to LA. That's, you want to come work for us. You love what we're doing. You love some of the people that are on the team, move to LA. No, we're not doing it. So we'd take a very cloud native approach and cloud first approach to running our team. This is just a quick note on process. Some things I've already mentioned, so I'll skip over this slide quickly. But we started, our very first employee we hired at the end of July last year, and then picked up steam after that. I think our 14th employee was, our 13th was in February, and our 14th was just like 2 months ago. And then we did call it a first playable around GDC timeline earlier this year. We announced our studio in March, right before GDC. Then we announced the game with that trailer in just before Gamescom in August. On that trailer, we got 1.9 million views in the first 3 days. That was awesome. Clearly, there's some excitement in the market for this game and for what we're showing. So that's great. Then we also day-to-day use the kind of tools that I'm sure a lot of you guys use, or some version of tools like this. Jira for all of our task tracking. We're not sending post-it notes to each other, right? Slack for a ton of communication across the team. Of course, when you're, sun never sets on the Roman Empire. Sun never set, at least in the past, and sun never sets on Empty Vessel. So there's a lot of Slack messages. We use Discord for any meetings, we call it face-to-face or voice-to-voice meetings. We also use Discord and lean on Discord for our voice chat for the game. We don't have that set up in the builds, so we use that and we actually separate the teams out into different channels. And then we playtest. This is, as I mentioned earlier, this is brand new IP. We want to smooth the rough edges off as much as we can early. Critical part of our process. Yeah. Okay, so let's get to an architectural diagram. Woo! You guys are in this room, so I know you've seen 1,000 of these. So this is basically the overview of how our build pipeline is set up up on AWS. Most of this is up on AWS. And I'm just going to walk through it quickly. You guys have questions, save them at the end, come up and we can come back to this slide. P4 server, and again, I apologize if you guys are all doing this, apologize. That means I guess we see eye to eye. If you're using the same things doing the same things that we're doing. Our P4 server lives in the cloud, lives up on AWS, an EC2 server. We actually we make package builds on almost every CL. Light days, we do a package build on every change list. When we get busy, there was a lot of check-ins coming up to our the build, we call it a thin vertical slice that we shared with a lot of people on site in Germany. We did a lot of playtests, so there's a lot of check-ins coming in hot and heavy the last 3-4 weeks of that. So we were doing package builds probably once a minute or once every few minutes. The goal there is that we can quickly troubleshoot crashes, quickly troubleshoot functionality that broke. This was working yesterday, why isn't it working today? A lot of times the engineers can look and just say, okay, well, it's a broken animation. There was this animation check in here, so we got to check with Taylor. But Taylor's in the room. But other times we say, okay, well, it could be a combination of different things, right? And again, towards the goal, Way has also a great DevOps architecture and just kind of software development background more than necessarily a games background. So as the architect of our systems, he's been really strong there and been really valuable there. So we kick off a lot of builds and we store those builds in S3, as you guys can see here. In Perforce, when a new CL comes in, or if we're batching them up 4 or 5 CLs at a time, we kick off, send a message out to the build. We have these builders, right? Multiple builders. It shows 3 here, but there's multiple builders. We use the AWS EventBridge. If you guys know what that is, it's awesome. If not, it's basically a message queuing system to make sure that a builder's not building the same build that another, off the CL that another builder's already kicked off on, right? Huge waste of space, huge waste of time. Messaging system sends to our builder, says, okay, we're ready to build, go, go, go. Compiles a source, compiles a blueprint, pulls, grabs all the latest assets, and then packages it up and compresses the build, and then stores it locally for a minute, and then sends it to S3, an S3 server in AWS. At the end of each day, as we play test, like I said, 2 times a week that we're scheduled, but oftentimes there's extra play tests in there. We always are testing latest, unless there's a Gamescom, we locked in the same build. We did take a couple of builds at the very end, Emmanuel, but we mostly locked down for that week, and then we're play testing every day or every couple of days on last night's changes, right? And so one of the guys in the engineering team, used to be Wade, one of his guys now, does a quick 20-minute smoke test, and then that build goes up, push that build, the client to, there's actually three components to the build that are built, right? There's the client that's built, it's roughly 10 gigs. There's the dedicated game server that's built, it's about 1.5 gigs. And then there's a local host, which we'd only use for kind of quick troubleshooting if we don't want to, pull together people for an online, quick test to smoke test something and kick off a server, restart server. So they'll do a quick smoke test and then we'll get in the full, then they'll push it, like I said, out to Steam and to another EC2 server. And we have, like I said in that one of those slides before, we have hosted game server in Tokyo for some Korean tests and some Tokyo tests. We mostly play in a server we set up in North Carolina, or North California. We always say North Carolina because it says NC. It throws us all off. North California. We've got one in Austin we've kicked off, and maybe even East Coast, and then also in Europe for our team there. And then, of course, when we were in Germany doing a bunch of play tests, we set up game server there, so we had faster ping. We also, last thing I want to mention here is he also set up an awesome system to kick automated pass-fail messages from the build servers into Slack. Most people mute that Slack channel because it's a lot of noise, but it is very valuable. So we get our to see if our automated test has passed in a certain CL, and we do catch I call them mistakes before checking mistakes usually before they ruin our playtest the next day, which is awesome, or ruin our playtest with potential investor, either existing investor or future investors. Is there any other notes I want to make on this slide? I don't think so, but I can always answer questions later. I'm going somewhat quick through this stuff, but which is fine. This, if you guys don't use AWS, I'll explain it. If you do, great, you've seen it. This is just a map of our the amount of data we're storing so far. Started in June, we were down below like 500 gigs, so it kind of didn't show up here. But we started kicking off a lot more builds, had a lot more assets, art assets coming into the build. And then we found it was getting a little bit too heavy and it was getting somewhat expensive. And so we used, they have a life cycle management tool, easy tool in the dashboard. We trimmed down the number of builds we saved to 5 days now, which still is probably a little bit overkill. But we store 5 days worth of builds because we're doing potentially 40 to 50 builds a day, right? And so we have fewer days that we store. We do have, of course, you can call them label builds or special builds that we store out, like our Gamescom build we store out. We still have our GDC build, even though it's very old at this point. But any sort of checkpoint builds, we, of course, store out. And then, of course, we can recompile to any of our change list numbers and have the build pipeline set up and build from that if we ever needed to go back that far. This is not only speeding the process up for our team now, but is also, I feel really good that we are future-proofing ourselves when we go from 14 to 44, right? Or when we have, 50 full-timers and 100 contractors, working on the build. This will also help us when we get to the point of having a large QA team, and we can hand off a lot of this management to them with Waze oversight. Oh, hey, I'm going to play another video for you.
Hi, thanks for watching this presentation. I want to spend a few minutes explaining our game development infrastructure and how we build it in AWS. The first and the most important thing to know is that we didn't get there in one try, and we haven't reached the end of this building process either. It took multiple iterations, and we continue improving it every day. Now, looking at the big picture, we can see 3 fundamental pieces. There is the version control and the build pipeline. There is the game server fleets, and there is the event pipeline. They correspond and empower 3 data flows. The first is the game development flow. The second, the game event flow. And the third is the user flow. Let's take a look at them one by one. Like many game studios, we use Helix Perforce version control system. We are hosted in our AWS account in a VPC dedicated to our studio DevOps. We build our in-house build system on top of Unreal Build Tool. This build and deployment system listens to the Perforce submission events, then executes the build process on one of the virtual machines. I'm going to skip the details as Garrett will cover it. The artifacts produced in the build process are saved in an AWS S3 buckets. S3 is great for storing large unstructured data. We use that S3 Lifecycle Manager to keep the most recent build files for up to 5 days to save storage costs. We also back up certain important milestone builds to a separate bucket. Now, moving on, our release engineer will evoke the orchestration process to install the latest game server on the EC2 virtual machines. We manage our server hosting ourselves to keep things simple and easily customizable. This is likely to change in the future when we need to scale up to serve tens of thousands of concurrent players. One thing worth noticing is that we have great experience using the Graviton3 powered EC2 instances, such as C7G. We have done extensive comparisons between the x86 and the Graviton3 variants. The result is that at the same cost, the Graviton3 variants deliver better performance than their x86 counterparts. I would highly recommend it to other studios, especially now that Unreal Engine 5 and its build system support Linux ARM64 out of the box. I'm more than happy to elaborate it in a separate demo if we have time. We designed our infrastructure to be region agnostic. As you can see, there are multiple VPCs running in various regions. So we can spin up game server cluster in a few seconds in any region within AWS reach. Once the game server is up and running, it starts to produce many real-time events. Events such as, who shoots whom because we are building a first-person shooter, who has accomplished the key objectives, what phase the game is at, whether it is in the beginning of the level or the climax. The server will also emit many performance-related metrics and events, such as the time taken to simulate physics and time to replicate movements. All these events originate in their text form in Unreal Engine logs. We have developed a robust system to parse and compress these logs and send them down in the event pipeline. Now let's take a look at this. The event pipeline and the corresponding event flow are the most important constructs to keep the game live. The event system running next to the game server will publish the key gameplay events to AWS EventBridge, where they are dispatched to various destinations. I'm not going to cover all the destinations because we're short on time, but I will highlight the most important destinations, which are the AWS Lambda functions. Lambda functions are lightweight computing units that scale up really quickly concurrently when the workload increases. You can think of them as a swarm of bees. Because of their small footprint and tiny runtime overhead, they are a good option for building real-time event handlers. We have defined a list of event dispatching rules in the AWS EventBridge, so it knows how to dispatch an objective achievement event to the gameplay event handler, whereas a performance event will be dispatched to the performance event handler. I would really love to talk more about this event-driven architecture in depth, but due to time constraint, I'll have to keep it brief. If you would like to know more, please let Garrett know. At the end of this event pipeline, all the event handlers need to persist the data in reliable storage so the player's achievements are saved and performance metrics can be utilized. This reliable storage is AWS DynamoDB. As a NoSQL database, DynamoDB enables our developers to build the data processing logic first, then worry about schema. Well, in plain words, we can store any kind of events there first, and then design how to utilize the event data. Once we're done building the event processing logic end-to-end, we can come back to refine the data, such as removing redundant information or adding more. DynamoDB enables highly reliable and a highly scalable workload, which is exactly what we want for building a robust multiplayer game. Let me give you an example of how we utilize the data stored in the DynamoDB. When a player playing our game or about to play our game, it will download the game client from Steam first. When the game client starts, it initially runs in a special standalone networking mode, which means the game isn't connected to any backend or dedicated server at all. When a user goes to the login menu, things start to get interesting. The game client communicates with a front-end server that recognizes the user. And therefore, the server sends back a connection token and address to the user. What happened under the hood is that the front-end server needs to query DynamoDB and find the current running server that matches the user's profile. We typically call this process matchmaking. The user used the address to make a connection to one of our dedicated servers. Then, once the dedicated server validates the connection token, it welcomes the user. The user begins to play with other players. DynamoDB is the center of these operations because it must know the up-to-date server status in real time. For example, it must know which server is shutting down and avoid replying the front end with its address. Luckily, DynamoDB guarantees strong read and write consistency by default, with plenty of configuration options to tune to improve performance even better. Now, let's take a few seconds to look at the big picture again. this time with all the flows visible. We can see that all these flows happen at the same time simultaneously. As our game developers are making changes to the version control system, our build pipeline produces new versions of the game and installs them in the EC2 servers. When the players connect to our game and start playing, the in-game event flow from the server to DynamoDB via AWS EventBridge and the event handlers. This seemingly complicated infrastructure is built by a very small team of developers with a low budget. And it's only possible with AWS because it gives you all the tools and services out of box. Thanks for watching. If you have any questions, please feel free to raise them in the Q&A section. Thanks.
That is our talk today. So in summary, we're very focused on optimizing our development workflows by pushing our build pipeline to the cloud with AWS, a great partner. And we would not be anywhere near where we are right now if it wasn't for leaning on the engine, Unreal and Epic's help and all the new things they're doing with Nanite and Lumen and the Metalite stuff. If you guys saw that yesterday, we're really impressed with. But pushing our workflows into the cloud, build pipeline and dedicated servers, huge benefit to us, not just from a playtesting standpoint, but also from keeping people productive. Number two, playtest. This is more of a process thing. We obviously have the tools, as you guys just saw, to support our playtests worldwide, but also it's kind of a linchpin to how we have set up the studio and how we run and how we manage ourselves in literally from a week-to-week basis, and how we are focused on making a high-quality, 90-rated AAA game. And we're big believers that the future of this industry is bright. There may be some bad news out there every now and again that we hear, which is unfortunate, but this industry is growing larger every single year. Yes, we had a big spike when we had COVID, and we're coming down a little bit, but that's still on a really great trajectory for us and all of us in this industry. And when you make great games, you will find an audience, guaranteed. So, and yes, everybody in this room and everybody at this conference, keep rocking it. The best way to predict the future is to create it. Further resources, yes, I know you guys all know this already, but just to remind you, if you're interested in AWS and you have used it before, go to their site. They have a ton of great resources there, great information there, including hooking directly into people who are working in Unreal. And then, of course, Unreal has great support information up there. And I think, thank you. Thanks for your guys' time.